Okay, so welcome Demi, Esme, Henry, Hudson, Isla and Thomas. Thanks for joining it live. As always, I'm recording it, so if anybody joins late or misses it, you can play the recording on either Teams or YouTube. So before we get going, just a reminder, please, to Henry, Lucas, Seb, Milo, Sam and Evie. I'm really keen that everybody gets a bit familiar with the Dr. Frost maths. Okay, we've been doing a lot of Hegarty, and Hegarty is excellent, and I wouldn't have it any other way. But the Dr. Frost maths does just give me a few other options. But I don't want to assess another Dr. Frost maths exercise until I know you're all comfortable logging in. So I set an exercise, a short sort of algebraic exercise about a week ago. To be honest, I'm not overly worried about how you're doing it. Okay, I just want to see that you've been able to log in properly and you can just see how the whole thing works. So please could Henry, Lucas, Seb, Milo, Sam and Evie make it a priority just to try and find out how to log into the Dr. Frost maths. And if you can't do it, let me know and I will help you. So what we're going to revise today is how to factorize expressions. Now, I've said to you before, in second form, it really just seemed a little bit of a kind of pointless sort of mathematical exercise. On the one hand, we expand to get rid of the brackets, and then another time we do the opposite to put the brackets back in. Now, it's only when we get into third, fourth and fifth form that you really start seeing why this is a useful mathematical tool. But for now, just be satisfied with being able to do the technique. Okay, so factorizing. When a question comes up and says factorize, you've got to think, okay, I need to put the brackets in. So I'm just going to work through the types of question that you'll be getting in Hegarty. You'll be getting in Hegarty 169. Okay. So 169 is going to be the homework. So, as I said, 169. So 10 questions, and the majority of them start off and they say the word factorize. Now, when it just says factorize and factorize on its own, there's just going to be one component outside the bracket. So, for example, it might be 8, open up your bracket, stuff in your bracket, close your bracket. Or it might be a letter outside the bracket, stuff in your bracket, close your bracket. But when it says factorize, there is just a single component outside the bracket. So they won't remind you of that, but you've just got to realize there's only one thing to take out. So what you've got to do, and I've got 4 examples here, you've just got to find the highest common factor in each of these terms. So we're looking for the factors, hence why it's called factorizing. So your thought process, is there a common factor within 8 and 7? No, there isn't. I mean, apart from 1, they do not have a common factor. 2 doesn't go into them both, 3 doesn't, 4 doesn't, and so on. So you can't factorize with regard to the numbers. Now, what about the letter P? Do we have any P's in common? Well, yes, we do. We've got a P squared to start off with, and remember that just means P times P, and we've got a P in the second term. Okay, so we've got a P times P and a P. So what's common to both? Well, we've got a P in both. So with this one, to factorize, we can take the P outside the bracket. Now, your thought process is, okay, if I was working backwards and expanding, what would I multiply P by in order to get 8P squared? Well, I would need an 8. Now, as things stand at the moment, P times 8 is 8P. Do I want 8P? No, I want 8P squared. So I need another P. So we've got 8 P times 8P, because when we multiply those together, P times 8 times P, or 8 times P times P is 8P squared. You then move on to the second term. So this is your thought process. What sign do I need? Well, I need to include a plus sign. And just either actually in your workings or just in your head, picture that second clause. Now, P times what is going to give you 7P? P times what is going to give you 7P? Well, you need a 7. Close your bracket, and that is your final answer. And they're easy to check. You just make sure when you expand, you get back to where you started. Now, question 2. Question 2. Same process. What factor can I take out? Well, 2 goes into both 4 and 6. So I can take a 2 outside my bracket and I open up my bracket. 2 times what gives me 4? Well, 2 times 2 gives me 4. Get the sign right. I need a minus. Now put in your second clause. Now 2 times what is going to give me the 6? Well, I need a 3. 2 3s are 6. But I don't want 6, I want 6x. So I've got to put in an x as well. And that is my factorised answer. Okay, 2 times 2 is 4, and 2 times minus 3x is minus 6x. Okay, question 3. Can I take out a number here? No, I can't. Apart from 1, there isn't a whole number that goes into both 2 and 5. Can I take out any y's? Yes, I can, because I've got a y squared and a y. So what's common to both? I can take a y outside my brackets. Open my bracket. Y times what gives me 5y squared? Well, I need the 5 and I need another y, because y times 5y is 5y squared. Get the sign right. I need a plus sign. Second clause, y times what is going to give me 2y? Well, I just need the 2. That's my final answer. Because y times 5y is 5y squared, y times plus 2 is plus 2y. And then finally, at the bottom, can I take out a factor from the numbers? Yes, I can. 6 is common to both. You've got to get out the highest common factor. So don't think, oh, yes, I can take out 2, or, oh, I can take out 3. Yeah, they're both good, but you've got to take out the highest common factor. What's the highest number that goes into 6 and 12? So I take a 6 outside. Open bracket, 6 times x is 6x. Get my sign right, 6 times 2 gives me the 12. So those are what the majority of the opening questions are like. In this exercise, you're just being asked to factorise. Now, the final few questions are slightly differently worded. They're asking you to factorise completely. Now, that word has got to mean to you that you're going to be taking out more than one component. So maybe you're taking out 2x and then at the bracket. Maybe you're taking out xy and then the bracket. You could even be taking out 3 components. All right, so whenever you see the word factorize completely, you must make sure you take out at least 2 components from the bracket. So my thought process here, what's the highest common factor of 14? Well, it's 14. 14 goes into both 14 and 14, obviously. What's the highest number of p's I can take outside the bracket? Well, it's a single p. Open up my bracket. 14p times what gives me 14p squared? What am I missing? I'm missing a p, because 14p squared means 14 times p times p. So I'm missing a p. Get my sign right. Now be ever so careful here. This is tricky. People often get this wrong. I've got 14p. I need 14p. The temptation is to say, I don't need anything more. Well, you kind of don't. But what do you multiply 14p by in order to stay on 14p? You've got to multiply by 1. So make sure you put a 1 in there and you don't put a 0 in there. Right, question 2. Factorise completely. So I know I'm taking out at least 2 things. What's the highest common factor of 4 and 8? That's 4. What's the highest common factor of p squared and p? That's p. Open up my bracket. 4p times what gives me 4p squared? I need a p. All right, then pop the plus sign in. 4p times what gives me 8p? I need 2. Okay, third one. What's the highest common factor of 15 and 9? Well, does 3 go into them? Yes, it does. Does 6 go into both of them? No. 3 is the highest common factor. And then what's the biggest number of z's that go into both z squared and z? That's a single z. Open my brackets. I could be careful here. Take it bit by bit. Start off with the numbers. 3 times what gives me 15? That's a 5. Z times what gives me z squared? That's another z. Get your sign right. 3 times what gives me 9? That's 3. Do I need anything else? No, I don't, because 3x times 3 gives me 9z. Don't need anything else. My work is done. Now, lots going on with that final one. Work your way along. What's the highest common factor of 5 and 10? Well, that's 5. What's the highest common factor of z cubed and z squared? What's the biggest number of x's I can take out that's common to both? Well, that's going to be an x squared. And then finally, what's the highest common factor of y squared and y? What's the highest number of y's that's common to both? Well, that's a single y. So on this occasion, you can see I've taken out 3 components. Open my bracket. Now, what do I need to add in here? I need another x and I need another y. Get your sign right. And what do I need to get this? I just need a 2. So I've already got my x squared and my y. So that's it, folks. Sorry that was quite a long explanation, but there is quite a tricky topic, this. So good luck with those. I'll leave you to get on with those. And those people I listed at the beginning, if you could just find time to try and log into Dr. Frost Maths and have a quick go at those questions, that would be great, because then it frees me up to setting some Dr. Frost Maths work another time and not making it just Hegarty all the time. Okay, guys, good luck with those. As always, I'll be here to help you and to transfer your marks and comments across to Teams. Bye.